Hello everyone, my name is Dina Ata. I'm working as a petroleum engineer at Khalda Petroleum Company. I will be your moderator today for the session. I want to welcome all of you and Dr. Mohammed Gharib will be our presenter today. Dr. Mohammed Gharib has a PhD degree in petroleum engineering with specialty in artificial lift and production engineering and operation. He is a member of petroleum engineering staff Future University in Egypt. Dr. Gharib is a technical and business professional with over 34 years experience in oil and gas business, operation management, engineering, sales, and teaching. Dr. Gharib was Vice President, Director, and General Manager for different international service and operation companies. Over the past years, he also has played a major role in the practical training for the field staff and engineering in oil and gas, production engineering, and well operation for different major companies in MENA region, USA, Canada, and the Far East. He was a SPE Egyptian section president, program and membership chairperson. He published and presented over 55 technical papers. He chairs several technical sessions for the local and international conferences and workshops. Dr. Gharib is a 2011 and 2020 recipient of the SPE Regional Technical Award in Production and Operation. We will have an amazing session today. I wish all of you to enjoy it. So now, Dr. Mohammed, you can start, and the mic is yours.
Thanks, Dina. Thanks a lot for these good introductions. Assalamu alaikum. Good morning, good afternoon, good evening for all of you. Today, I'd like to give you some introduction about one of the very interesting subjects. It's sucker rod pumping system, and the name little bit changed a while from sucker rod pumping system to reciprocating sucker rod pumping system. This in order just to differentiate between the progressive cavity pump system and the normal reciprocating sucker rod. In the past, since about more than 50 to 100 years, only you have sucker rod pumping system using the rod string. But recently, about 50 years or 60 more, the progressive cavity pumping system is using the same rod lift. In order to differentiate, let us all of us just to start to talk about this type of system to named as reciprocating rod lift system. Sucker rod or reciprocating rod lift system, it's one of the very old subject for lifting fluids from ground. You know, if you look to the picture in the right, this is just a shadow system. It's the same concept, still the same of today for just the most updated technology reciprocating rod lift system. It's using different type of system to activating the pump. Today presentation will cover just in very brief, in very brief, and maybe we have another sessions to go in details, I will give you some little bit introductions and what are the main system components at the surface and downhole components. Will cover the well completion for the rod lift system, subsurface pump, rod string, and the surface equipment like the surface pumping units, what the prime movers running for that, what is the well heads of sucker rod looks like. There is a very simple well heads, and currently there is a very complicated well heads using with Saudi Aramco and so on. And I give you one or two slides about analyzing the sucker rod pumping system, what the techniques is used. And later on, we can go in details for each of that component. We talk in the introduction of the artificial lift system that there is different type of artificial lift. Either we are using formation pressure to assist the fluid to reach to the surface with a certain wellhead pressure capable to move the fluids to the separators, and mechanical assist. Mechanical assist, there is different types of mechanical assist. Today, our subject will be about rod lift system or reciprocating sucker rod lift system. This type of artificial lift using since more than 5,000, 7,000 years. Currently, over 72 to 75% of the artificially lifted wells are using the sucker rod pump, the reciprocating rod pumping system. It's not only just lifting the oils, it's also in some area it can be used for gas wells. How can be used for gas wells? We can go in detail later on about this one. What is the reciprocating? What is a sucker pumping system or reciprocating pumping system? This is a picture for the whole system, from surface to the downhole, The sucker pumping system, it is the most popular artificial lift method, the mechanical method, pure mechanical method, used worldwide, as I said, more than 75 to plus or minus. This number of the well are using rod lift system to lift from 1 barrel per day up to over 6,000 barrel per day. It's just using what we call using a surface pumping units just to convert a rotary motion of a prime movers, can be electric motor, can be diesel engine, can be gas engine, whatever source of rotary here is through the beam pumping system is just converted to reciprocating, and reciprocating pumping action is just required to activate the downhole pumps through a mechanical link called the rod string. Okay. What are, the application of this? As I said, more than 75% of the wells worldwide are using this type of wells. Why? And why we sucker rod, and what type of application we can use the reciprocating rod lift system? First of all, the sucker rod or reciprocating lifting system can be used for all well or fluid condition. Sandy wells, if the well produces a very high percentage of sand, for sure there is a problem. Sand is a problem for all mechanical, for all artificial lift types. But how you can handle sand? Sucker rod currently can handle a certain percentage of sand. There is a wells in Oman, for example, if you stop the well for an hour or less than an hour, you can have 1-2 joint over the pump full of sand, gassy wells. You can use a rod lift system for very high gas or ratio wells. In the old books, they said sucker rod for liquid, for dead oil, for liquid, but currently there is a multi-phase downhole pumps. Then rod lift system can use for gassy wells. It's used for all type of crude oils as heavy, medium, APIs up to more than 50. Some units is living wells with more than 50 APIs, And also, this type of artificial lift is a mechanicals, completely mechanicals. Then it's not affecting too much with the pumping pressure or the bottom hole flow pressure. It's kind of working if the fluid level at the pump. If only you have a fluid here. This slide just can summarize for you what is a typical application for the rod lift system and so on, Rod lift system can use for all type of wells, whatever the percentage of sands can be used. For sure, there is a problem, and there is a special design, special downhole configuration for the sand. Sand is a problem for all type of artificial lift, especially mechanical types. Rod lift system can use for very high gas or ratio wells. Currently, as I said, there is some wells using gas well using rod lift system to dewatering the wells and so on, due to the new technology and new configuration in downhole pumps, what we call variable slippage pump or just multi-phase pump. And also this type of artificial lift can be lifted type of fluids, whatever it's API gravity, it's from 8, 10 up to more than 50 APIs and so on. Also, since it's a completely mechanicals and it's a positive displacement, it's not, the bottom hole flow pressure is not affecting too much in the volume of production. However, since you have a fluid covering the pump or just enter the pump can produce from fluid up to the pump depth, from the pump depths up to the surface and so on. This type of artificial lift can be used a very wide range of production from 1 barrel per day up to more than 6,000 barrels per day. Also, due to the new technology and so on, this type of wells can be used for all well geometry, for all well trajectories, vertical wells, horizontal wells, slant wells, deviated wells. For sure, each type of problem or well condition, it's required a special design in downhole condition, It's used for steam injections, if you're well under steam injection or just steam flooding or just SAG-D, whatever, this type of artificial lift, it can be used easy and it can be handled all the type of wells. As you know, just this table just to summarize for you the application range. For example, you can use from up to 16,000. There is a wells in different area using up to more than 17,000 barrel per day, 6,000 barrel per day, and so on. Even for the temperatures, you can use up to 550 degree Fahrenheit and more. And all this is just type of application for road application for that. Why they are more than 75% of the world using road lift system, you know, and so on. Why the people start to use more and more road lift system? According to the most of application, most of studies, they said, if you are studying and screening, selecting the artificial lift for your wells, and you found the reciprocating sucker rod pumping system can work, use that system. Why? Because they have a very high system efficiency. The losses in power between the input power to the system and the output power to the lifting of fluid you are lifting, it's not too much, you know. It's come after the progressive cavities. The second type of artificial lift just can be have low losses in the power between. All the optimization control, it's available. You can optimize the system from the surface to control the downhole equipment and the surface equipment. If you design the system to produce, for example, a 1,000, 2,000 barrel per day, and due to a depletion in the reservoir, the production it's dropped and the fluid level dropped to more pressure, dropped to, and production dropped to about 20, 50, 100 barrel per day. Using this optimization, you can adapt using the same system to have the same production. Positive displacement, for that reason I said, you know, you can displace up to fluid level up to the pump depths, and also you can create a very high pressures at the wells, you know, because it's positive displacement. I will show you later on in how the pump, downhole pump running to understand what's mean positive displacement. If you have a problem with the material, you design the pump initially, especially downhole condition for sweet condition, sweet crude oils, and there is no CO2, and with the time you found this problem start to be appears, you can change the downhole condition material and so on. As you have a very high flexibility to change the pumping parameters based on the bottom hole condition. Very high salvage value because majority of the wells cost in the surface equipment. 75% of the artificial lift cost as a road lift system is in the surface equipment. Then they have a very high salvage value and so on. For sure, like all the other artificial lifts, they have some limitation. One of these limitation, I said before, one of the application, it can be used for a deviated well, for horizontal well. But even if we are using for that, the running life, the mean time between failures will be, it's not high, you know. Then there is a potential of tubing and road wear. Then design, you need to have a special design, special roads, special downhole configuration in order to match special pumping parameters and so on, you know. Gassy wells, yes, there is a problem for gassy wells for all artificial lift. If you have a gas, the volumetric efficiency will reduce. But this type can be produced a very high gas ratio wells, and you can improve your downhole volumetric efficiency. Is the depth limited? For sure, it can use to 16,000, 17,000 feet. But with increasing the depths, the load over the road string and the pump will increase. Then the capability of the production will decrease. Then the amount of loads you are able to produce will decrease. For example, you can produce 7,000 barrels per day, but this from depths about 700 feet, 800 feet, 1,000 feet maximum. But from 17,000 feet, you cannot produce more than 100 barrels per day and so on. You cannot use an area while the people it's living or just like offshore area. They have some environmental effects and some environmental problems and so on. What are the system components? The previous slides just introduction. What are the main system components? Let us just to divide it to surface equipment and downhole equipment. You know, if we are look to downhole equipment, the first downhole equipment, the first part, let me just give you some hint about it's the sucker rod well completion. what I need to consider in the well completion for the road lift system. The well completion for the road lift system is one of the simplest well completions, and only just you need to have some of these, or just maybe all of that. You need to have a production tubing, and production tubing can be the tubing, or some people can use a casing, can use hanging the pump inside the casing, and you can produce, no problem, with a special downhole configuration. But if you use tubing, and so you need a sitting nipple, you need to set the pump in a certain sitting nipple. Plus, for a certain type of well, when you are the depths increasing more than 3,000 feet, 4,000 feet, there's a tendency of the tubing movement with the bump reciprocating. Since you require what you call tubing anchor catchers, and so on, just to eliminate it, tubing movement, and so on. Plus the wellhead of the sucker rod, and so on. In a very simple way, if we assume this is a casing and this is the formation, you need just to run the tubing. And with the tubing for shallow wells, you need only to have the sitting nipple. This is a very simple completion for the road lift system for well produced from 3,000 feet and shallower than that, and so on. This is the only one. And then you can run the pump. This is a downhole pump. You run the pump over the road string and sit inside the sitting nipple. This is a very simple completion for the road lift system. What else? But remember, this sucker rod is moving up and down. While we are moving up, this is the road string, and this is a tubing. This road string, and this is a tubing. This is a pump, and this is what we call traveling valve. This is standing valve. While we are going up in that case, one of that valve, what we call traveling valve, is closed. Then you're lifting the weight of the fluids. What is lifting the traveling valve with a plunger is a rod string. Then all the weight of the fluids will be on the rod string, and the rod string will be under tension. But there will be no fluid load on the tubing itself. Then the tubing is contracted. You have this shape of buckling of the tubing. In the downstroke, this valve is open, and all the weight transferred to the standing valve, which is connecting to the tubing. And then the fluid load transferred to the tubing. This is a tubing, its expansion. Then you have tubing movement with each stroke. In that case, you need to have what you call tubing anchor catcher, just to fix the tubing with the casing in order to prevent the tubing movement while the pumping cycles. Then you need to have, in the previous slides, we said I need to have tubing plus sitting nipple. Here, with the wells producing from 3,000 feet, some people use 4,000 feet or 2,000 feet, depend on the pump size and some other condition. You need to use what you call tubing anchor catcher. Tubing anchor catcher is used just to eliminate tubing movement. Eliminate tubing movement just to eliminate to reduce tubing wears and reduce coupling of sucker rod wears, and even the tubing coupling can be connected, and we have some friction with the casing, and this can have another problems. And this will be the other very simple. Then two simple completion for road lift system. For sure, there is some complicated completions and some other requirement completion, like what we are using in Algeria and some other area in Saudi Arabia and some other area. They are using a downhole sensor with the pumps. They are using a downhole, what you call injection, fluid injection, just to melt some salt and to reduce the salinity. If you need the downhole monitoring, a lot of things, sometimes you need to reduce from two different zones, and you need to separate the two zones. You need to run the two backers and so on. But however, the majority, more than 85% of the well worldwide using the two type of completion, what I presented before. What are the heart of the road lift system? It is the sucker rod downhole pumps. The downhole pumps, all the people name it is the heart of the pumping system. All the system used and designed to operate this downhole pump. If you operated this downhole pump in a good efficiency, then you will have a very good efficiency for the total system. It's just some symbols assembles of small pieces, small parts, and can connecting together and just what we call to complete downhole pumps. Let me show you later on what this is, piece of parts connecting and the downhole pumps compressed oil. What are the function of downhole pumps? I said before in the introduction of artificial lift, the function for any downhole pumps. Any downhole pumps have two main functions. First of all, the downhole pump should be decrease the bottom hole flow pressure against the formation. Why you need to decrease that? In order to allow the formation to produce or to give to you the design or desired production you want from the formation. Meanwhile, after you are reducing this pressure, you need to lift it to the surface. How you need to lift the surface? This pump should be increasing the pressure again, the discharge pressure after the pump in order to allow to lift the fluid to the surface and just with the wellhead pressure and overcomes pressure loss with the wellhead pressure capable to produce, to move this fluid to the nearest separator or the tank and so on. How the downhole pump is running and how it is working. As a pump cycle, we have two cycles for the pump. When the pump is going up, when the pumping unit is going up like this, we call it upstroke pumping unit. When it starts going down, we need this downstroke pumping units. What's going on in the upstroke pumping units? The downhole pumps have two main valves. This non-return valve, it check valves, open in one direction, open from bottom to the top, and open by delta B. You need delta B across the pump to open the valve. And the change when the flow direction, close when the flow direction is changed. Then this is standing valve, this is traveling valve, the red one, this is the plunger, and this is the rod string, this is the tubing. While we are going in the upstroke, this is plunger and the valve, traveling valve. When you start to go up in the upstroke, it start to go against the flow. Then all the fluid pressure above the pump will be over this valve and will close that valve. Then when you start to go up like this, what will happen? This valve will be closed. Since this valve will be closed, all the fluid pressure above the traveling valve or this valve will be isolated from the standing valve. Then will be no pressure in the top of the standing valve. What will happen? Below the standing valve is a formation pressure. It's a bottom hole pressures, the low pressure. Then this pressure will open the standing valve. Because here the pressure is very low, there is no pressure. Then will be opened. While we are going up, this is traveling valve is going and displace all the fluid above the traveling valve in the plunger to inside the tube. Meanwhile, this is the area will be just vacant area. Then traveling standing valve will open. The fluid from the formation start to fill this traveling valve until we reach to the end of the upstroke. Then will be if you have enough fluid to fill that, in ideal case, in ideal condition. Then the fluid below the valve came from the formation. This is a blue one, and this will be completely full with a new fluid. What happened in the downstroke? Then you are reached to upstroke, you are reached to here, and you have new fluid in this area. From here to here is a new fluid. When you start to go down, the pumping units going down, it's called downstroke. What will happen here? This flow is going down. This is fluid. The direction of the fluid will be changed and affecting on that pole. Then this pole will be closed. When this is traveling valve start to move down, will move against closed area. This is fluid, incompressible. Even if you have gas, you have some compressibility of gas. This valve can be a little bit closed until reach to a certain pressure. And this valve go down until creating pressure below that valve in this area will be higher than the hydrostatic head of the fluid column from the pump to the surface, plus wellhead pressure, plus pressure loss. At that condition, this valve, what you call this pole of seat of this valve in this shape, this valve will be open and start to displace the new fluid what we are creating in the upflow to be moved to the up above the traveling valve until you reach to the end of the bottom of stroke. Then all the fluid what you already produced in the Upstroke, you already transferred the downstroke, and the cycle start to repeat it again, up and down, up and down, up and down. This one cycle, up and down, called one stroke. The units can be around 10 strokes per minute, then 10 cycle, up and down, one cycle, 10 times up and down, like this. This is called the one stroke. The number of stroke is a function of how much production I need from this way, and so on. Generally speaking, just since I said that road lift system now is using for different type of fluid, for different type of condition, can be used for sand, high volume, low volume, and so on. Then in the market, there is different configuration of the pump. API start to differentiate it between the pump. The main two categories, API divided the downhole pumps to two main categories. One is called tubing pump. Tubing pump, that's mean a part of the tubing is a part of the pump is run as a part of the tube. This is a part of the pump, what you call pump barrels outside the emitter. It's run connecting to the tubing as a part of the tubing, and the rest will run on the rod string. The other configuration is the insert pump. Insert pump, that means the whole type of pump is run inside the tubing. Not only that, because also, as I said, the road lift system is a forgiving system. It's have a lot of technology used for a variety of different condition, different fluid condition, and so on. And even for each type of this category, there is a subcategories. The first subcategory and main purpose used, and the majority of the people use what we call insert rod pump. Insert rod pump, that means the whole pump, it's run inside the tubing. If you have this tubing, remember the compression, I said they have a tubing and they have a setting nipple. Assume this is the tubing you have, and what's mean of insert pump? Insert pump, that's mean the whole pump, whole type, the whole complete set of pump connecting to the rod string and run inside the tubing, like this. This is tubing, the tubing, the setting nipples. Insert pump, that's mean this can be go inside this one, this plunger configuration will be inside this pump, and this connecting to the rod string, and the whole pump connecting to the rod string and runs it. Not only that, just even for this condition and for insert pump, it's not only have just we can say insert pump and so. Insert pump is there is different type of pressures, different type of accumulation sand, and so different type of condition. Even the manufacturing, the API manufacturing, the insert pump to different condition. For example, what's mean they are manufacturing insert pump for different condition? I will explain the difference between both of them. Even for insert pump, according to the pump, where is hanging the pump? If the pump, the whole pump, pass from the setting nipple, or the whole pump can reach to the setting nipple and the complete pump can be set above the setting nipple. In that case, the APIs or just the manufacturing defines the pump to two type of pump. One of them called top anchor pump. Top anchor pump, what mean? The pump is connecting from its top. See the red point? This is the anchor assembly of the pump. And all the blue pump is a pump. If this one connecting at the top of the pump, in the whole pump, it's passing from the setting nipple, and only just the cage of the pump can be in the top. What the other configuration of the insert pump, the API is found. This is a setting assembly of the pump and so on. The other type is what's called bottom anchor pump. This is setting assembly, this type, this setting assembly here in the bottom, What's the difference between them? And why you have top and bottom anchor pump? For example, if I have a sand and I'm producing the well with some sand and so on. Remember, road lift system sometimes can be reduced 100 barrel, 200 barrel, 50 barrel. Then the fluid velocity of the velocity of the fluid is low. Then the sand carrying capacity will be low. And suppose sometimes the well is stopped for any reason to do some maintenance and so on. Then the sand can settle between the pump barrels and the tubing. If the pump start to settle here, the pump can become stuck and you're not able to use. Then if you have some sand and some tendency, this type of bottom anchor pump, It's not preferred, it's not recommended. It's recommended the top anchor bomb. Someone can say, okay, since the bottom anchor bomb is good for that, why are not used only top anchor bomb for all wells? No, because top anchor bomb also have some other problem. The whole bomb should be passed from sitting nipple. Then the bomb size here inside the same tubing will be less than the bomb sizes. Not only that, remember in the downstroke, the traveling valve, in order to open, the pressure below the traveling valve should be higher than the whole hydrostatic head, plus the wellhead pressure. But the pressure outside the bomb here is low. Then the pressure here is low, the pressure here is high. Then the inside pressure inside the bomb will be very high. The bomb can have some ballooning effect, and even the barrel can be broken, can have some pressure. But here in the downstroke, the pressure outside will be like the pressure inside, and so on. Tubing bomb, for the tubing bomb, it's a little bit different than the insert rod bomb, you know. As I said, the tubing bomb, part of the tubing is a part of the bomb is a tubing. These are bomb barrels, you know, and this is a sitting nipple. And this sitting nipple, and this is a bomb barrel. And these are plungers, you know. For tubing bomb, you run this with the tubing as a part of the tubing. Then you run the standing valve or just the sitting assembly, either separate like this or connecting with a plunger and run with the plungers here, and after that you can set in the well. This is a plunger assembly connecting to this one. This is the difference between the tubing bomb and the insert bomb. What are the main components of the bomb? Since we say the bomb is the heart of the system. Whatever type of bomb you have, insert bomb, top anchor, bottom anchor, tubing bomb, whatever type of bomb, all the bomb must have 5 main basic parts, plus some other connection. And if you look to this bomb, if you count the connection of the bomb, we found almost 22 pieces of the bomb. But 22 pieces like a nut and some other connection. But the other heart of the system, the main part, it's only 5. First one is the barrel, the housing of the bomb, the barrel of the bomb. Second part is the plunger. The plunger is a sealing element which is moving inside the part, which is a seal the fluid from the top to the bottom. It's not allow the fluid what we are producing in the upstroke to bypass the bomb and to back again. Plus 2 valves. All pumps have 2 valves. These 2 valves, it's traveling valve and standing valve. All 2 valves have these 2 configurations, pole and seal. Non-retain valve, check valve, open from bottom to the top, open by delta B. Plus the sitting assembly, you know, where is you are set the bomb? At what place you are set the bomb? It's in the bottom or in the top. In the market, there is different type of sitting assembly. There is a cup types, plastic types, and also there is a mechanical types. There is depend on the well condition. These cups can be in the bottom, these cups can be in the top, and so on. Plus, one of the main advantage of the rod lift system, even if you not have the sitting nipple in the well and you have a temporary well completion and you need to run the pump at a certain depth, there is what we call insert pump anchor. This pump anchor you can connect to the bottom of the pump. You can remove this is sitting assembly and connect to the bottom of the pump, and you can run inside your tubing and you can set the pump at any depth of the tube. For an example, if you have a flowing wells and flowing wells cease to flow and there is no workover available and you want to produce this well, you can produce this well using rod lift system by using insert rod pump. If you have a tubing leak in some area and so on, there's different application for that one. When we start to go in details for rod lift system class, we can explain this more and so on. Okay, this is just other rod lift system. Generally speaking, in a very brief way, you know, the API, even since we have variety of pump, different type of pump, top down, bottom down, insert pump, tubing pump, you know, mechanical anchor, mechanical cup types, and so on. The API said, okay, let us to have one configuration, one designation. Then all the people worldwide can talk the same line. Since the API configures the pump and define the pump with a certain configuration, it's very important for each one work in this area to know that. You know, they define the pump at what tubing size you need to run the pump. This is the first 2 digits indicating the tubing size. For example, if I have 278 tubing size, then the first two digits to designate it, to define the pump, will be 25. That means this pump will run in 278-inch tubing. If you have this tubing, then the pump size, the three more digits after that, is referred to what pump size, what the pool pump size here. It should be run here. If you have a smaller pump, you cannot have a smaller tubing, you cannot run with a bigger pump, maybe not pass inside the tubing. The first two digits give you what is inside the diameter of the tubing. Second two digits, it says this can be run here on that. This can be, yes, this can be a rod pump, can be a tubing pump, and what size of the pump. Plus, this pump can be a rod pump or tubing pump, a rod pump, tubing pump. Plus, if you see the tubing and rod pump, the barrel, it's just to withstand the pressure inside. Is the barrel thickness, the wall thickness is the barrel. It's high, heavy, or thin is wall, and so on. It's a pump connecting from top or the bottom. Remember, we say you have top anchor and bottom anchor of the pump, and so on, you know. The barrel length, how much far are you going in the upstroke? When you are going in the upstroke, you need to have a barrel length accumulated, can be accumulated this stroke length. And stroke length is one of the main parameters required and used to calculate the production with the speed of the pumping speed. What is the plunger length? This is the length of the plunger, is a sealing element. What is the length? Sometimes there is some two connection at the top or the bottom of the pump called the pump connection. Let me give you an example to be a little bit clear on that, you know. The API, if the API says, okay, I have a pump, 25, 150, RH, PC 12, 5, 3, 4. And this is my downhole pumps, and this is my tubing. 25 means this is tubing size is 278 tubing size. 150, if you put a point here, that means that my pump size, plunger size, or inside the diameters of this pump, it's 1.5 inches. Then when you start to calculate your production, then you have now here's plunger size, you have stroke length, stroke per minute. What this type of pump? If you look at this type of pump, all the pump is outside the tubing. This R, it's mean insert pump or rod pump. R, insert pump or rod pump. What else I have here, you know? The barrels, thickness of the barrels. These barrels, you know, this is thin wall barrel, this is the heavy wall barrels. These barrels, the thickness of these barrels, you know, it's heavy or heavy. In order to withstand high pressures, you know, the design is required, this one, you know. This pump is a bottom anchor. See, it's bottom anchor, you know. This is the anchor of the pump sitting assembly of the pump connecting from the bottom. Then this pump is bottom anchor pump. Cup types, you may see here, it's cup types. It's not a mechanical. This is a plastic cup type, easy to unset and set this pump. This barrel length from here to here is 12 feet. This 12, it means the barrel length is 12 feet. Then 5 feet, what's the 5 feet? Is the plunger length. This plunger length is 5 feet. So plunger length depends on how much delta P across the plunger. If I run a plunger in deep wells, for sure I need longer plunger to withstand more pressure across the plunger. If I run in deep shallow wells, maybe I need 1 feet plungers, 2 feet plungers. Sometimes if I run in deep wells, I need 7 feet plunger, 8 feet plungers, and so on. 3 feet, that means this up extension, the upper extension, upper connection in the tubing is 3 feet. 2 feet is the lower extension, the tubing is 2 feet. And this just, you know, each one should be known that this is API configuration, API designation of the pump. But remember, this is about pump configuration and size. Nothing here about pump metallurgy. Yes, because I hear from some people, they say, okay, I need an API pump, 25, 150, RHPC, and so on, API, and it can be run for all the well. No. Depend on downhole condition, your sour condition, your well fluid condition, you need to change after you designate the pump. This pump configuration is related to the pump size and how you run the pump and how much production you need from this pump. But metallurgy, what type of condition this pump you run, you need to change each type of piece of the pump metallurgy. and so on. This is 3 feet top, and this is 3 feet bottom. The other part in downhole equipment, what we call sucker rod strings of the pump. What is sucker rod string? The rod string, it's a mechanical link connecting the this is downhole pumps, and this is my service equipment. I say downhole pumps, in order to run, it should be reciprocating up and down. It receives the reciprocation up and down from the pumping units. This is going up and down. But what is connecting this reciprocating transfer, the reciprocating motion from top to the bottom of the pump? It's what we call the sucker rod, the rod string. Sucker rod, the rod string, it's just, there is different type, different configuration. This is the simplest way, the more common configuration of rod string is used worldwide. I will show you on the next slide what's the difference between this and me. Since the rod string is connecting the pump to the service equipment, then in the upstroke, the rod string, it's just lifting its own weight plus the weight of the rod fluid connecting to the top of the traveling valve. Then rod string going up and down, one of the many critical important parameters in the sucker rod configuration. It's subject to cyclic load. In the upstroke is lifting its weight plus the weight in the downstroke. In the downstroke, there is no weight flow. Then you're lifting only its own weight. Then the rod string is subject to different load in upstroke and downstroke. If you are remembers, if you are just have a very simple calculation, this system is running with 10 strokes per minute. Then this rod is going 10 times up and down with different load in upstroke and downstroke per minute. That means 14,400 times per day with different loads. Then we need to select, this is a very critical, very careful rod string, you know. What type of corrosion environment? You select the size, and you have a corrosion environment, you have some pitting, some cracker to reduce the tubing cycle and so on. What size of coupling? This coupling connecting joint to the other. What size of coupling here, you know? Because the coupling, the fluid will pass between coupling and the tubing. And if this area is small, especially for heavy crude oil, this will be a very high pressure loss in this area and so on. What type of rod string, you know? There is different type of rod string, all since about 200 years or more. There's only wooden rod string. With the new technologies, rod string manufacturing and the requirement for produce deep wells, heavy wells, and high volume wells. In the market, they will find they are introduced many types of rod string. But however, the main common rod string is this one, what we call jointly sucker rod, jointed sucker rod. Sucker rod is about pieces and joints. You can connecting as a well side to each piece and joint. First one is a special steel conventional sucker rod. Special conventional steel sucker rod. Plus there is a hollow sucker rod. Sucker rod, this sucker rod is just a solid bar. The normal sucker rod is solid bar. But there is for a special application, small application, this can be a hollow sucker rod, but this will be very limited load. Plus some people start to introduce what we call fiberglass sucker rod. The body of sucker rod is fiberglass. Remember, you know, just I said the capability of the rod lift system to produce high volume from deep wells will be low. Why? Because when we are going deep, you need to lift weight flow plus weight of the rod string. Because when we are going deep, the weight of the rod string is increased. Then manufacturing starts to introduce something light, like fiberglass. But however, each one of them have some advantage and disadvantage. One of the main disadvantage of the fiberglass is the temperature, is the elasticity. If it's broken for the fishing operation, it's not an easy answer. And currently, really, in the market, there is a very good type of rod string, what we call it's continuous sucker rod string. Instead to use a jointly sucker rod string can be about 25 feet, 30 feet, and so on like that. No, they are using one piece of sucker rod from top of the well to the bottom of the well. Came in this reel like that's called continuous sucker rod, which allow all the operators can be run sucker rod for horizontal wells, can run the pump in horizontal well. It's allow also the operators to run the sucker rod for very high deviated wells and so on. Then This is just the main component of saccharode. Then when we start to talk about saccharode string, that means the road from the bottom of the pump to the pumping unit to the surface. All this called saccharode string. What are the main component of the saccharode string? Either you need to have connection of this or that, or just a continuous saccharode, plus coupling if you are using connecting saccharode, plus you need to have ponyrod, just a small saccharode like a pub joint in the tubing and sort to connect the final length of the saccharode. Plus at the top of the rod string, you need to have a polished rod. Polished rod is connecting the saccharode, whatever you have down all this or that, to the pumping units, which is a part of the polished rod, go up out of the well and in of the well. And there is a rubber connection called stuffing box, is just connecting to the polished rod to allow the fluids not to go out. Then the main component of the rod string from bottom to the top or from top to the bottom can be polished rod, pony rod, and this is the main rod connection plus the coupling and so on. If we start to talk about steel, the main common, more than currently 70% of the oil using saccharode, the main common saccharode is a steel, common two different lengths, either 25 feet or 40 feet plus, if you are counted for the coupling and so on. It's available 25 or 30 feet. It's just the two end of this saccharode is a male, and the coupling, you can connect in coupling female and female in the coupling. Diameter of saccharode, there is an API standard for saccharode. It's starting from 5/8 inches up to 1.5 inches with an incremental of 1/8 inches. For example, after 5/8 inches, if you add 1/8 inches, will be 6/8 inches, that means 3/4 inches. And if you added 1/8 inches to the 3/4, you will have 7/8 inches, you have 8/8 inches, and so on. Plus the bony rod is just a saccharode, is with a small length, can be 2 feet, 4 feet, 6 feet. According to the ABI standards for saccharode, there is 3 main ABI grades. Grades that mean how much load, how much tensile strength this saccharode can be withstand, and so on. According to the ABI, there is grade C, grade K, and grade D. Plus you have high tensile strength saccharode is not ABI, because the ABI saccharode have a limited capability to run a certain load, overloads. But sometimes, you have a heavy weight, heavy loads, deep wells. What you need to do? The manufacturing start to manufacturing a saccharode with more capability, more capacity than this. It's, for sure, it's more expensive. It's sensitive to handling because the hardness will be very high and so on. And sometimes, it's creating big problem in handling in the field, even if when it's used. Saccharodes came in this bundle, in the shape of that type of bundle, and so on. The second type, the new technology of the rod string, really, it's called what's called continuous saccharode. If you look to this one, this is a jointly connecting saccharode, what just I explain, this saccharode joint connecting together with a jointly. In order to bend saccharode in this area will be very hard, because saccharode will be a little bit stiff. Plus the coupling outside the enter, it's high. Then you're creating here what you call a very high friction loss, side loads in the tubing. Then you have friction, very high side load between the tubing and the coupling here. Then this will be a very high wear tendency here, But if you look to this continuous saccharode continuous like this, coming in just one piece, little bit flexible, then all the weights is just distributed in the low side areas. And if you have, for example, side load here, 50 pounds, then 50 pounds will be distributed for the coupling length, about 4 inches. But here, 50 pounds will distribute it over the whole joint if you have the bending area about, for example, 10 feet, 15 feet, then the side load here for each point will be much, much less. Not only that, if you look to this is a standard saccharode, the flow resistance of flow to pass between the coupling and the annulus clear area between the couplings and the tubing will be very low. There will be a very high pressure loss and creating also piston effect even here, you know. But for continuous saccharose, there is no coupling, only one, it's one joint connected from top up to the bottom. But one of the main problems for this one, it's required a special rig to run this, and this is not available in all the area, you know. The handling is, and transportation, it's a little bit expensive. But for horizontal work, for deep wells, for some other special application, it's proved to be a very good type of road and so on. Since we said the sucker rod is just used only at the mechanical lens from top to the bottom, then nothing else I need from sucker rod, especially for sprocating rod lift, and is lifting its own weight. Then why I use one side of sucker rod from top to the bottom? The top part of sucker rod is lifting all the weight of sucker rod below it, plus the weight of the flow. But the bottom part of sucker rod is lifting only the weight of the flow. Then why I used bigger size of sucker rod for all size? Then the API start to say, okay, let us to design, especially for deep wells, sucker rod, what we call tapered type rod string. Tapered type rod string, that's mean I use a bigger rod string in the top and smaller rod string in the bottom, but should be distributed smoothly. You know, I can use one size and the second size should be exactly less than the one in the top was 1/8 inches. Remember I said that the sucker rod changed from one size to one size was incremental of 1/8 inches. That's mean the 1 inch is over, it's about 8/8. And 7/8 inches is 7/8. 3/4 inches is 6/8. In order to have a tapered rod string like this and design, there is a special design formula I can use like this special software like S-Rod and Roadstar and some other roads, Q-Roads, and so you can use to define what configuration of this need to use. If it is API, the stresses, you know, at each top of this is different road size should be equal. What's that mean? If I start to load this road, this 1 inch road, grade C's, was about 85% of its maximum capacity, then I start to go with like this until we reach to the point here, change 7/8 inches was 85 each of its maximum capacity. Then the top part of this size equal or just expecting or just have a road stress the same like the top part of this one, like the top part of this one. In this case, we called ABI road string. And the ABI road string defined with the top one and the bottom one. For example, like the road lift, if you see the road lift, the downhole bumps, it says ABI defined with a certain configuration. For also the taper road strings, ABI defined with 2 main numbers. You said, I have a road string in my wells is 86. 86 taper road strings, that's mean your road string have 3 sections of the road. In the top, it's 1 inches, in the bottom, it's 3/4, and between both of them, it's 7/8. Let me give you also one example, you know, for this. As example, if I said I have my API road string 65, 65, that's mean you have 2 taper road string, 6 and 5, 3/4 and 5/8 of inches. 88, what's mean? I have the road string from top to the bottom, all is one size, 1 inch, but I must have 2 digits, because I define with 2 digits. 97, that's mean, 97 tapered API road string, I have 9, it's 1/8, I have 1 inches, I have 7/8, then I have 3 tapered road string. Then the tapered road string, it's used just to reduce the weight of the road string itself. Nothing else it's required. If reducing the weight of the road string, you can also reduce the weight on the bumping units. Reducing the weight on the service bumping units, you can use smaller bumping units. Reducing the weight on the bumping units also can reduce the weight on or just the load and the motor. Then you can reduce the power consumption. a lot of function of are using tapered rod string. Then for the tapered rod string, again, in order to be API, the rod string distribution along its length, should have equal stresses at each top of each tapered rod strings. Sucker rod in the downstroke, it's only lifting its own weight. There is no weight in the downstroke of sucker rod. And especially for the lower part of sucker rod, will be no weights on the lower part. And the weights can have a tendency of buckling. Nothing will pull the weight from the bottom and will move against the plungers. Then the plunger is moving against the rod itself. Then the lower part of the tubing can be buckling. For that reason, the manufacturing or just the designer say, okay, sometimes if I have a buckling and the buckling tendency, buckling can create a big problems in the lower part of the tubing, can create a friction between rod and tubing, coupling and tubing, and so on. Then using what you call only heavy parts of the rods. For example, if you can use a rod with 1.5 inches, 2 inches, and so on. This is the sinker bar, the heavy bar, or just the heavy weights of the rod string. It's used just in the lower part on the tubing just to concentrate it all the weight to above the bump to help the rod string to be always under tension. The rod string will be under tensions in the upstroke, but what in the downstroke? The rod string will not be under tension. Then the sinker bar is required to provide concentration weights on the rod string, in the bottom of the rod string. Why? In order to keep the rod string will be under tensions on the downstroke, not in the upstroke. Assist the pump and the sucker rod string to have full easy, because in heavy crude oil, there is a bouncy effect. There is a frictions, just what's called viscosity frictions between the rod and the coupling, and the rod can move very slow in the rod. We need some heavy weights on the rod to let the rod to go move faster in the rod string, in the fluid and so on. The third part is if we start to come to the service equipment, it's the beam pumping unit, or just the surface pumping unit and so on. In the past, there is only one type of pumping units. This type, all of you just maybe, if you want to the field, you can count the majority of the people use what we call beam pumping unit or pump jack and so on. The main function of this pump, it's used to stroke the bottom hole pump up and down, And usually it's reducing the speed of the prime movers to the required speed to activate the down hole pump and converted the rotary motion of the prime mover to just the reciprocating up and down motion. Plus, it's carry all the weight of the well in the flow. Currently, really, because the producers, operator found a lot of problem using this well for high volume. For high volume, there is a limitation in the pumping speed. And when you're increasing the pumping speeds, a lot of problem downhole, it will be created, the velocity will be increased, the buckling will be increased, the friction will be increased, the load and downstroke will be decreased, and so on. Then the manufacturing start to manufacturing what we call long stroke pumping unit. There is a limited in a stroke of pumping unit. This can be reached to 240, sometimes a special design 260 inches. And this is a function of the production. What if you want more production? The manufacturing start to produce what we call longer stroke pumping units. This can be used to produce high volume, can to reduce the speed, and if you want to produce the same volume. For the long stroke pumping units, there is a mechanical type and there is a hydraulics type, fully automated pumping units, and so on. Also, API configured and designated the pumping units, the beam pumping units, this type of pumping unit with a special configuration, a special design. They said, okay, for the pumping, what size of pumping units I need? For example, this one. If you go to the field, we found different size, different shape, different configuration of pump size. What pumping units need to use in this case? They said, okay, first letters is give you what type of pump. In the market, there is different type of pump, but the majority of you found conventional type of pump, like this one. This one is a conventional type of pumping units. But in the market, there is different type. Then the letter C gives you what's the configuration, what's the type of pumping units you have. Then you say, okay, this pumping units is rotating is just converting the rotary motion of prime mover to reciprocating motion and reduce the speed. Then it's required a gear reducer. Gear reducer just to lift the float, meanwhile to rotating the pumping unit. Then it's required a certain torque. It's okay. For each pumping unit, you need to define what the maximum peak torque, maximum torque in 1,000 these units can be rotating, rotating the system and going up and down. Usually take this number and multiply by 1,000. Then the peak torque here is around 640,000 inch-pound. D is just this gear reducer is reducing the speed over two steps in two directions. Plus, this pumping unit is lifting, carrying the weight of the fluid plus the weight of the rod. But for sure, there is a maximum capacity for each unit. Then he just gives you a number like this. If multiply this with 100, he says this pumping unit is a maximum load on the polished rod, because the polished rod is the top part of the rod string is the top. Then the peak polished rod load, the maximum load, this unit can be lifted 25,600 pounds. What is the maximum stroke length going up and down? Maximum stroke length for this unit is 145 inches. If you look to these are conventional pumping units, if you are defined by, for an example, C912, D365, 168. What does this mean? This means this configuration. This pump looks like this one is just, a configuration. 912, that means if you multiply this with 1,000, this gear reducer can rotate this with the torque, because the torque is a function of the load and the distance, how far you have this distance from here to here. Then what maximum torque you can lift this, you can rotating this one. Plus, the peak load, how much load this 365, then 365,000 pound, how big loads we can lift it from here. Plus how much the maximum stroke length you can lift it, and so. Just to go to the prime mover for that, all this is introduction. We can go in details after that. We said the prime mover is the last end of the system. It's just the tool or the machine is required to provide the rotary motion to the pumping unit, which is converted through the gear reducers to a reciprocating motions, gear reducer and the pumping unit, and reducing the speed here. This can be engine, like this one. The engine can be diesel engine, gas engine, or can be electric motor, like this one. For sure, there is a different type of configuration. What does the sucker rod wellheads look like? Sucker rod, this is a polished rod. Remember, this is a polished rod. This is a polished rod going up and down. This is a pumping unit. For all rod lift system, you need to have a POP, because in case you have a problem here, you need to close this POP in order to have any repairs here. Plus, you need to have a stuffing box. Stuffing box is just like a piece of equipment, have a rubber inside. This rubber is closed over this polished rod. It allows the polished rod to go up and down without to allow the fluid to go out in the well. And so this is just in a very simple way in that. How we are analyzing, and we know the system is running and so on. One of the main famous piece of information is required from that, what we call the dynamometers. Dynamometers, it's just gives you the performance of the downhole pumps and the surface pump. What is dynamometers? Dynamometers, it's just, a relations between the loads in the vertical axis and the position in the horizontal axis. What mean of the load? Load, while we are going up and upstroke, You are lifting float, then the load will be increased. Then going up from here, the load will be increasing until we reach to the bottom of the end of the turbine stroke. Then while we are going down, the load will be decreased until we are reaching the, this will be called. We have two types of cards, surface card and downhole cards. Really, this is dynamometer card analysis and survey required more than 3 sessions, 2 sessions to go in detail and analysis. But however, you know, this one of the pieces of information is required for all pumping units. You can do just, this is using a portable dynamometer, or we can do continuous. This is what we call some equipment tool installed at the well site called well managers, which can measure continuously the load with the position, and we can measure the surface load and the downhole load, can give you the performance of the surface equipment and downhole equipment. Okay, there's different shape and parameters of downhole equipment. From each shape, we can know how the pump is running. Is the pump is running in with a very good efficiency? If the pump is running with a 50% efficiency? If there is a sand inside the pump? If there is a wear inside the pump? If there is one valve, standing dropping valve have problem? If there is some stuck inside the pump? From all that, we can know how the pump is running and so on. This is just an introduction, very light introduction about road lift system, because road lift system is required minimum 1 month daily session, at least like this. It's a system using worldwide more than 75% with new technology and start more and more wells is used. Thanks, and if you have any question, it's
Yes, thank you so much, Dr. Mohammed, for the session. And I have some questions from the students.
Okay.
Okay, the first one. Do we use multiple tubing catchers like centralizers in the rod pump? Yeah, okay.
No, tubing catcher, only one tubing catcher, because tubing catcher is used at the bottom of the tubing, either below or above the pump, and we are connecting the tubing to the casing. And connecting to the tubing in the casing in the tension. And while we are moving up or down, then the tubing is not moving. Only one tubing anchor catcher is required. Different type of tubing anchor catcher in the market. Can be mechanical, can be hydraulics, and so on. But no, we are using only one tubing anchor catcher.
Okay.
It's not a centralizer.
Yes. Okay, the second question, when we can use top and bottom anchored pump?
Yes, I mentioned like that, you know, where I just in very quick. Bottom anchor pumps I can use for deep wells when the delta P will be a very high across the barrels, you know, and the bottom hole pressure will be a very low, then I use bottom anchor pump. Or if I need high productions from the well while the insert pump cannot be, the top anchor pump cannot be used. Top anchor pump I use if there is sand, if there's debris on the wells, you know, I use a top anchor pump.
Okay. Dr. Mohammed, do you hear me?
Yes, sure.
Okay. The third question, how is the stresses distributed along the continuous rod in the continuous rod pump?
Yes, good questions. You know, yes, the stresses is distributed based on the load. The continuous rods in the top part of the continuous rod is lifting also the lower part of the rod. Then the top part of the continuous rod have the highest stress on that one. For that reason, currently, when we start to design continuous rod for deep wells, sometimes we use also a tapered continuous rods. Tapered continuous rod, we are welding the rod on the sides, or just sometimes we came from the factory, from the plant, it's welded together, you know. But yes, this is top part, it's will be a very high stresses on the top part of the continuous rod. And this is one of the main important problems for the continuous rod when we design. When we design this, we try to distribute the stresses, you know, very carefully over the continuous rod.
Okay. The last question I have, does the sucker rod used in the offshore
Yeah. Do you see this picture?
Yeah, we can see it.
This is offshore, huh?
Yeah, yeah. Yes.
This offshore. But however, you know, this is just, you know, a very special application. It's not an easy to use an offshore because offshore platform is limited as a size, area, and as a weight. But, you know, this is a very small unit and, you know, it's very limited. However, you know, currently, you know, with a new manufacturing for what you call hydraulic pumping unit like the one I mentioned, I showed you before, the hydraulic pumping unit light one, long stroke, this one, you know, it can be used even but with a very limited applications.
Okay. Thank you so much, Dr. Muhammad, for the session. It's very informative. And I want to thank all of our students for being with us today. And have a good day, all of you.